Now come to the cause of electromagnetic induction. In the experiment, we see that when the magnet approaches the loop, you see a deflection in the galvanometer. Okay. Since we know that each magnet has its own magnetic field, here in the diagram, these lines are the magnetic field lines of this magnet coming out from the north pole, and when the magnet during motion, consider the magnet is here, and in this position only single magnetic field line is crossing the loop. Okay, and when the magnet arrives near the coil, then the number of magnetic field lines crossing the loop increases. Okay, here 3 magnetic field lines are crossing the loop, whereas in the first diagram only 1 magnetic field line crossing the loop. So the magnetic field lines changes during the motion of the magnet. When the magnet approaches the loop, the magnetic field lines increases crossing the loop, and when the magnet moves away from the loop, the magnetic field lines crossing the loop decreases. So this is the reason for electromagnetic induction, that when the magnetic field lines crossing the loop changes, a current will induce in the coil. Okay, so this is the logic behind electromagnetic induction. Okay, only change in magnetic field linked with the loop plays the role in electromagnetic induction. Okay, now write down the statement of the electromagnetic induction, that is, when a closed conducting loop is linked with a changing magnetic field, an EMF is induced and hence induces a current in the loop. Okay, it means when a closed conducting loop is linked with a changing magnetic field, then an EMF is induced in the loop first, and when the loop is closed, then an induced current will flow through the loop. Okay, and the current in the loop lasts as long as there is a change in magnetic field. Okay, so when you stop moving the magnet, then the induced current goes to 0. And it is seen experimentally that the induced EMF in the loop is directly proportional to the rate of change of magnetic field. Okay, when the rate of change of magnetic field linked with the loop increases, the induced EMF also increases. Okay, it means when you move the magnet to and fro near the loop at a fast rate, then the induced EMF will increase. Okay, and the induced EMF is also proportional to the number of turns in the coil. Okay, when the number of turns in the coil increases, the induced EMF also increases. Okay, so note it down.